All right, so we're going to go on and talk about ionic bonding. The handle of this titanium mug was joined to the body by welding. At the welding temperature, titanium reacts with oxygen in the air, forming an oxide. The oxide makes the weld more brittle. Chemical properties such as reactivity depend on an element's electron configuration, or where the electrons are at. When is an atom unlikely to react? When the highest occupied energy level of the atom is filled with electrons, the atom is stable and not likely to react. So when the valence electrons fill up an orbital, it's good. The chemical properties of an element depend on a number of valence electrons. An electron dot diagram is a model of an atom in which each dot represents a valence electron. The symbol in the center represents the nucleus and all the other electrons in the atom. So here are electron dot diagrams for elements. Group 1, 1 valence electron, 1 dot. Group 2A, 2 dots. Group 3A, 3 dots. Hopefully you see a pattern going on here. 4A, 4 dots. 5A, 5 dots. 6A, 6 dots. 7A, 7 valence electrons. And again, the noble gases, remember helium only has 2 electrons, but everybody else has the full set of 8. Noble gases are the most stable elements. The highest occupied energy level of a noble gas atom is completely filled. The noble gases have stable electron configurations with 8 valence electrons, 2 in the case of helium. Elements tend to react to achieve electron configurations similar to those of noble gases. So elements want to react to have full outer levels. What is one way in which electrons can achieve stable electron configurations? Some elements achieve stable electron configurations through the transfer of electrons between atoms. So the transfer of electrons. A chlorine atom has 1 electron fewer than an argon atom. Adding 1 electron would make chlorine a stable configuration. A sodium atom has 1 more electron than a neon atom. Removing 1 electron would give sodium a stable configuration. When sodium reacts with chlorine, an electron is transferred from sodium to chlorine. Each atom ends up with a more stable electron arrangement than it had before the transfer. So the electron goes from sodium to chlorine. And now you have a positive charge and a negative charge. Positive because it loses an electron, negative because it gains an electron. When an atom gains or loses an electron, the number of protons is no longer equal to the number of electrons. The charge on the atom is not balanced and the atom is not neutral. An atom that has a net positive or net negative electric charge is called an ion. The charge on an ion is represented by a plus or a minus sign. When an ion that forms from the chlorine atom gains an electron, has 17 protons and 18 electrons. The charge is -1. The symbol is written like that. An ion that's negative is called an anion. Anions like chlorine or chloride are named by dropping the ene and making it I. Thus, Cl negative is called a chloride ion. Sodium has 11 protons and 10 electrons. The sodium ion has a charge of +1. The symbol for the ion is written Na+1, or Na positive for short. An ion with a positive charge is a cation. A cation uses the element name as is. So sodium is just sodium ion. Scientists use atomic radii to compare the sizes of atoms of different elements. The radius of a sphere is the distance from the center to the outer edge, half of the diameter of the sphere. Atomic radii are really small. They're measured in units called picometers. There are 1 billion picometers in a millimeter, so it's really, really small. This shows the atomic and ionic radii for 6 metals and 6 nonmetals. You can use this data to relate the size of the atoms to the element's location in the periodic table and compare the sizes of their ions and atoms. So you can see positive ions are smaller, while negative ions, they get bigger. So atomic radius, ionic radius. A particle with a negative charge will attract a particle with a positive charge. A chemical bond is the force that holds atoms or ions together as a unit. An ionic bond is the force that holds cations and anions together. An ionic bond forms when electrons are transferred from one atom to another. Ionization energy. Cations form when electrons gain enough energy to escape from atoms. The energy allows electrons to overcome the attraction of the protons in the nucleus. The amount of energy used to remove an electron is called ionization energy. The lower the ionization energy, the easier it is to remove an electron from an atom. So here's ionization energy. As we go across, it increases. As we go down, it decreases. So over here, they want to get rid of electrons, and over here, they want to keep their electrons. How does the structure of an ionic compound affect its properties? Solids whose particles are arranged in a lattice structure are called crystals. The properties of an ionic compound can be explained by the strong attractions among the ions within a crystal lattice. Compounds that contain ionic bonds are ionic compounds, which can be represented by chemical formulas. A chemical formula is a notation that shows what elements a compound contains and the ratio of the atoms or ions of those elements in the compound. The chemical formula for sodium chloride, NaCl, indicates one sodium ion for each chloride ion in sodium chloride. So let's look at magnesium chloride. Magnesium has 2, chlorine has 7. So magnesium gives one electron up to each chlorine. So 1 magnesium, 2 chlorines, positive 2, negative 2. Therefore, we know that this transfer of electrons leads to a positive 2 charge, negative 2 charge, which balances out, and it becomes MgCl2. Magnesium chloride is used to control dust on unpaved roads, so it's spread out on the roads. Crystal lattice. A chemical formula for an ionic compound tells you the ratio of the ions in the compound, but not how the ions are arranged. If you looked at a sample of sodium chloride with a hand lens or microscope, you would be able to see that the pieces of salt are shaped like cubes. The crystal shape is a clue to how the sodium and chloride ions are arranged in a compound. Ions in sodium chloride are arranged in an orderly three-dimensional structure. Each chloride ion is surrounded by 6 sodium ions, and each sodium ion is surrounded by 6 chloride ions. Each ion is attracted to all the neighboring ions with an opposite charge. This set of attractions keeps the ions in fixed positions in a rigid framework or lattice. So here's the structure of a crystal lattice. Each sodium is surrounded by chlorides, and each chloride is surrounded by sodiums. And that's what we would see in that shape. The shape of an ionic crystal, for example, the cubic shape of a sodium chloride crystal, depends on the arrangement of ions in its lattice. The arrangement of the ions depends on the ratio of ions and their relative sizes. Crystals are classified into groups based on the size of their crystals. Okay, let's talk about properties of ionic compounds. The properties of sodium chloride are typical of ionic compounds. High melting point, 801 degrees Celsius, so you can't melt salt, or easily melt salt. Solid sodium chloride is a poor conductor, but when melted, it's a good conductor. And then they're also brittle, so when you hit them with the hammer, they shatter. So, high melting point, poor conductor as a solid, but when melted, can conduct, and they're brittle. The arrangement of particles in the substance is the result of 2 opposing factors: the attractions among particles in the substance and the kinetic energy of the particles. The stronger the attractions among the particles, the more kinetic energy the particles must have before they can separate. Ionic compounds have strong attractions between particles, therefore they have high melting points. For an electric current to flow, charged particles must be able to move from one location to another. Ions in a solid crystal lattice have fixed positions. Solid sodium chloride is a poor conductor of electric current, but when the solid melts, the lattice breaks apart and the ions can move. So once the ions can move, this melted sodium chloride is a great conductor of electric current. Here's the hitting of a crystal. So we hit the crystal with the hammer, and you can see it will shatter when struck, okay? Because there's repulsion going on amongst these ions. Negative ions are pushing against each other. Positive ions are attracting negative. So when you strike it, you get a shattered crystal. And that's why it shatters.